welcome to today's virtual tour of VDOT's pavement testing facility. Our tour guide today is Mr. Travis Higgs, professional engineer, and Hokie from Civil Engineering 2004. The facility we're touring today is located right behind the Virginia Tech Transportation Institute, not far from ACO Quarry.
Yes, VDOT has partnered together for a number of years with research and Virginia Tech, and here at the Smart Road today we're actually continuing those efforts.
Could you tell us a little bit about what you're doing here today?
What we're doing here is, this is known as the HVS/APT testing site. That stands for Heavy Vehicle Simulator or Accelerated Pavement Testing Facility. And so we have 8 lanes set up of different types of asphalt mixtures. We partnered together with Virginia Tech, with the asphalt industry, and VDOT, of course, have partnered together to produce different experimental mixes of asphalt that we can test under heavy loading at an accelerated pace to age asphalt almost 10 years in just a matter of a couple months, and see that performance and see if we've got viable products that can go on the roadway. Yes, the mixes that we're checking into today and that the research project that we're currently evaluating is a new mix design method called balance mix design, which is designed to balance the performance and the volumetrics of pavement design. In the past, our mix design methods have all been based on volumetrics, meaning that we had certain ranges of ingredients that we put in the mix design. Now we're trying to add a performance mechanism to that, doing crack testing, rut testing, and durability testing. And so with that too, we're also venturing into seeing how much wrap we can put in our mixes, which is recycled asphalt pavement. So recycling obviously gives us the opportunity to be better stewards of the environment. We have an abundance of recycled asphalt across the state at our asphalt plants, where we've milled up old asphalt to put down new asphalt. So developing higher percentages that we can put in our asphalt mixes has industry benefits, and it has environmental benefits as well. So typically we use about 30% wrap in our mixes, but out here we're testing different mixtures with 30% in an optimized fashion to see if we can improve performance on our regular mixes. But we're also looking at 45% wrap mixes and 60% wrap mixes. What's that?
Illumination test, like candle testing?
I think different lighting. And then the rainmaker and snowmaker.
The Rainmaker.
Rainmaker and snowmaker.
I've been lucky enough to do the quick bus tour kind of thing where you go down and you get in the bridge, but I've never been here to see these things operating.
Yeah.
They've talked about the lighting tests though.
Okay.
On that tour.
Been part of any of those.
Just checking to look at markings, I guess.
Yeah. I know they've done some markings.
Look at this. Oh dang, I want one of these. Like for my driveway. I don't know why. So you're getting a vertical load as well as you're imposing shear on the surface.
It's actually Auburn, they have an NCAT test track, National Center for Asphalt Technology. They have a test track, and it basically looks like a racing oval, and it has different pavement sections, but they actually hire drivers to drive in circles with loaded trucks, and they do that continuously to try to create the same effect. What we're doing here, several other DOTs, Florida DOT's done it, I think maybe California as well, but several have made the investment in these types of accelerated pavement testers. Do the same thing in an automated fashion, and you don't need near as much land area either.
Well, plus you can move it, right?
That's yeah, they can move it. Yeah, it's kind of tricky, but yeah, it's got jacks for when it does the testing. You open up the jacks, and then they actually use a tractor, and they can move it from lane to lane.
Oh, wow. And how long is the run?
The lane, what we're doing is the test lane is 300 feet. We've got 5 50-foot test cells in each 300-foot lane. The ends we didn't do anything with, just to eliminate those because of variability of starting and ending. But yeah, the middle is broken up into 50-foot test lanes, and so that machine can actually test 100 foot, but by decreasing it to 50 feet, we can actually test add more loading faster. And actually, it has side panels to where we can actually simulate higher temperatures. We can go up to well over 100 degrees because it's got heaters in it, or we can cool it and take the temperature way down and simulate low temperature loading as well.
Wow.
Gets a little expensive to heat that and cool it though, so we try to avoid some of that if we can, but at different times we do heat and cool it.
So is this VDOT sponsored research, or who's doing this?
Yeah, it's VDOT, and it's we actually bought the machine. We're paying and getting all the pavement down. We have a research leg at VDOT called the Virginia Transportation Research Council.
Oh, okay.
It's in Charlottesville, UVA. So
what a terrible
I said,
place
yeah, I know, not a good place for it, but they have done good for us for a number of years. I'm not even sure when it first started, but it's been around at least 30 years. In the Research Council and VDOT and VTTI has gotten involved. We work so well with our research partners that VDOT is really on the cutting edge of technology and pavement innovations and implementation.
So what's going on under the panels?
Nothing. They just took them off because they moved the machine, so they have to take them off to move it. But those panels are just insulated panels. This is actually a great time to see it because normally those panels are up and you can't see anything.
Yeah, you were talking about that, and I'm like, where are they? They flip up, but there they are.
Those are side panels so that it holds the heating and the cooling.
Wow, this is a pretty cool device.
Oh yeah. It was a $2 million device.
Oh, is that all?
Yeah, that's all.
But I mean, this is amazing. There can't be too many of these.
No, there's not. There's not.
Huh.
I don't know the exact number. Like I said, I know Florida has one, and I think a couple others might too. But yeah, no, we're very fortunate to have this, and look to get a lot of use out of it and gain a lot of information. And we were talking earlier, Leanne and I. The FHWA has called us and asked a lot of questions about our findings, and actually gotten us in touch with other DOTs, Nevada DOT and others, to talk about some of the things we've already learned. Because this balanced mix design, pavement, asphalt is kind of an old art form, but trying to implement new tools in it to improve it. That's what this balanced mix design is all about, because we were talking a little bit earlier about the key to asphalt is density. Also for longevity, it's getting enough liquid in the mix, and so that's what balanced mix design is all about, is getting enough liquid in there to prevent raveling, cracking, premature aging, but not having too much liquid in it to where you start having rutting and flushing and slick pavement. So that's we're trying to hit the holy grail of asphalt mixtures, whereas the old system we've always used, volumetrics, having specific ranges of ingredients that we put in it, they just don't zero in on the performance aspects well enough, and so that's what we're trying to accomplish.
So at a typical VDOT site, you're getting material from a plant somewhere else, brought in on trucks, right?
Yeah.
Although I know there's also some milling and in situ stuff. I mean, to what extent can you modify the mix, like right then and there on site? Is that something that's ever done?
Not on site, but by the time you get out on site, you pretty much have what you have at that point. But at the plant, it's all about that's one reason why it's taking so long between loads here is because we're dealing with natural materials. There's inherent variability that comes with that. There's aggregates that they're not widgets, they're not produced in a factory, so they have natural variability. Even your wrap, recycled asphalt, depending on where those millings came from, different asphalt mixtures and different size mixtures. It's another piece of variability. Temperatures are a big part of asphalt too. You have to, for different mixtures, you might need to crank up the temperatures a little bit higher. On different ones, we actually have warm mix that we've worked on to lower temperatures and operating temperatures at plants for environmental and fuel consumption reasons. And so there's a lot of different aspects that go into it at the plant, so that hopefully once that mix gets out in the field, it's just laying down and ensuring that we get density for longevity.
That's pretty cool.
Yeah.
What about extending the season? Is that something people are working on?
Yeah. That's been talked about with warm mix additives, because warm mix allows you to put it down at cooler temperatures. We've actually been looking at the opposite, trying to shorten the season here recently. So we're using more polymers in our mixes that add to some of the tensile strength that you can get with asphalt. So if we get more polymer asphalts out there, then hopefully we're not paving as often, and we can actually have shorter paving seasons because of that. But those polymer additives and some of the additives that go in the mixes start to require higher temperatures to be able to place. But typically in Virginia, we're well suited for pretty good paving season. We got to have 40 degrees to pave. When you get below 40 degrees, you have trouble getting good density. You lose too much temperature from the plant to placement in the field, and once you lose temperature in that hall, then compaction becomes very difficult. Once you get below or close to 150 degrees, the mix is usually leaving the plant at about 300. Once you get to the field, you got to do all your compaction between that and about 150, 175. At that point, you're done. You can't compact it anymore.
Where are you getting the asphalt for these studies? Are you getting them from
This is coming from Salem, actually.
From Salem. Interesting.
Yeah. So it's that's what we were talking about earlier, that it's coming out of the plant at about 300. The first load got here and it was 285. The second loads that we had come, they were there was an accident on the interstate, so they had to take Route 11 and got detoured a little bit. And one truck, the first truck was 275 and the second one was 235. And so it was a little bit less, and so they had a little bit of trouble compacting it because it had already lost some heat. So they had to increase the number of roller passes. And that's one thing we had talked about too, is what we do as far as checking and testing the mix in the field is we have a nuclear gauge. I saw one.
Was it hanging off the back of a pickup? No, that was something else.
Should be manned. Somebody should be with it because it is a nuclear source. But anyway, so
not laughing.
Yeah. So I don't know where it is at the moment, but yeah. So what we'll do is we'll take passes with a roller, and they'll use a nuclear gauge, and they'll check the density, and then they'll make an additional pass as long as that density reading keeps going up. Once it gets to a breaking point, and then it starts going down, that establishes your roller pattern, and that's what you need to continue for the rest of the placement. And then you can actually increase your testing frequency at that point, just to keep a spot check. And if you have density issues, if you start seeing that number go down, then you run another roller pattern and check every pass of the roller to reestablish a new pattern.
Got a couple of layers on here, right?
Yes. Yeah. So we've got 3 inches of asphalt on this one. All of these are 3 inches. Because we're doing a comparison study of different mixes, and like I said, trying to find the one that gives us the best bang for the buck as far as cost and performance. We wanted consistency, so yeah, we've got 3 inches of asphalt on all these lanes.
So the edge here is just 2 different passes with the roller? Is that...
Yeah. Actually,
okay.
This edge right here, what we were doing, this is totally non-test related. Each lane is 10 foot wide, which is about the distance or the width of a standard lane close. It's 10 to 12 feet. This one is actually 11.5 feet wide because what you're standing on right there is actually a French drain. You'll see the difference in the aggregate. It's 57 stone. We had some trouble early on because we were getting some inconsistent results out here, and they found out that what we believed was a big source of it was water was coming off of the building.
Wow.
And there, because the downspouts just drain this way, and it was draining into the stone and going underneath the pavement and messing with our test results.
Whoops.
And so we put in a French drain here that it's 57 stone, and there's a 4-inch pipe underneath it, and so water now comes off the building, comes here, goes down and drains into a storm structure at the far end of the parking lot down there. So this area is just a gap between the test area. So this outer 2 foot's just an apron, and then this is the actual lane that will be tested.
Oh, the actual. Jeez, I've got my profile in the shadow here. I can't see anything. So you're taking.
That's a core test location. So when we do nuclear testing, that's what that square is right there, and then that 148 by nuclear gauge, they got the 148 pounds per cubic foot was the measurement. And then what we do is we actually take a core, we saw out a core, and we verify that by checking the specific gravity of the core in water and making sure that it's close to the nuclear gauge value. And
do you take a rectangular cut, or are you doing an actual round core?
No, it's actually square. So what they do is they make what is that, 1, 2, 4, 5 cuts, and then this one end piece right here they pop out, and it comes apart, and then they pop out one solid square. So this one part down here is just so that they can get a screwdriver under the core and pop it out in a solid piece.
And are they how many layers are they taking at that point? Just the top lift?
Just the top lift. Yep. Yeah, they actually use CO2 to cool it down rapidly, so that because if you try to do that on hot asphalt, it would fall to pieces. So they actually use CO2 to cool it rapidly and then cut it out. And so that's kind of what the smoky pattern and stuff is around some of these, along with the dust from.
Interesting.
Yeah.
Okay. Wow, this is fun.
Because we actually have a little bit of a failure right there that the mat started tearing a little bit on us when they were rolling it. And again, that's just from the edge being unconfined over here on the right side, and it's a little soft on the sub-base stone, and so that's
well, looks like you have some. Oh, that's just going under there. Those aren't sensors.
Yeah, no, they go underneath. They're in the aggregate, or right at the top of the aggregate in the asphalt. So yeah, they're. I think you've got strain gauges and pressure plates maybe in there.
Interesting. Huh. So you edge constrain on a road when you pour it? Is that the standard? That's interesting.
Yeah, when we mill, we have confined edges, but on sometimes when we do new construction, we have unconfined edges like this. And so edges of pavement are always a little bit tricky depending on the condition of what's adjacent to it. So in this case, where like I said, the outer 1.5 feet was going to be problematic anyway, and so I think that's what kind of happened, because we had prepped the stone really well for a 10-foot width, but then we said kind of at the last minute, well, we want to go ahead and pave this and not leave a gap between this French drain. And so I think in doing that and pushing that, it pulled the mat and tore it a little bit right here in this area. It's kind of unfortunate that didn't happen anywhere except right in that location.
Well, it's good you have redundancy, right? So when you do a test, are you repeating it? You said there were 5 segments, and you're doing the middle 3?
Yeah, actually what they're doing is there are 5 cells, and so they do 3 of them are rut test. I can actually show you one of the ones where they've already rut tested it. And then 2 of the test cells will be used for crack testing. I'm not sure what the variance is in the way they load it, but they'll load it to evaluate for cracking performance from the bottom to the top. But the rut testing, I can show you it. A good example of it.
Are y'all doing any studies on repaving or overlays or anything like that?
did. That was kind of a trial and error. The last 2 lanes over there are concrete. And we were doing a reflective crack study.
Oh yeah, jeez.
But have had limited success with that. I'll just say it that way. Now this was the section that was just tested before they moved the machine over there in the middle of September.
Okay.
So here's the rutting and
Oh wow.
like I said, this was tested at a very accelerated rate in a quick manner. So I'm not sure how many loads you're looking at, but it is significant.
Do you know what the weight is roughly on it?
I do not right off the top of my head. Most of the time, let's see, I think it's about 18,000 pounds, but I'm not sure on that. That's what they're measuring. The load count, they measure it in easels, equivalent single axle loads, which is an 18,000 pound load, but it might be as high as 24,000. I'm not real sure off the top of my head.
Interesting. I had a student in civil engineering. She was studying rapid runway repair.
Okay.
And so she talked a lot about the kind of impact testing they did to capture the plane's wheels when it first hits.
Okay.
And what a mess that is, right? Yeah. And it's interesting to see that, I mean, in essence, if you're doing shear, well, this is rutting, right?
Yeah, this one's rutting.
So,
yeah.
But you are looking at shear as well.
Yeah.
Sometimes it's
so that far one down there was rutting. This one's rutting. We did another one with rutting. The middle 2 will be cracking. This one's interesting. You were asking a question earlier about tack. I was telling her we don't tack this because we're paving it all in the same day, so the mix is still pretty warm, still over 100 degrees or so. Yeah, that's the little pop out from the core. So.
Hey, cool.
Yeah.
Don't suppose this could be a souvenir? Oh, wow.
Yeah. But right here, you were asking about bond. This one, after only just a few loads, the mast started ripping and started shoving, and we right here, it's kind of smooth right down there. So what happened is we think that either the mat got dirty right there, or there was a rain shower between it was a day like today, but then this was actually paved in June, so it rained real quick before we were able to get the second lift on. And so there is some thought that before that second lift got down, that the rain caused a bond breaker right in this part. It's only in this section right here, so the next section didn't have a bond issue, but obviously bond greatly affects the durability of a pavement.
My God, it's that fussy. Mm-hmm. If it sprinkles rain a little bit.
Oh yeah. Well, yeah, it's supposed to be. It didn't seem like it had done that much, but a ponded water, that's what VDOT specs say, is as long as water's not ponded, it's okay.
Wow.
But it must have just been enough, or like I said, or it was dirty in that spot. I'm not sure what occurred right here, but something happened right in this area that led to a D-bond between lift 1 and lift 2, and that pavement tester this is exactly reminiscent of what you would see in the field. I've actually seen this several times myself when we've had trouble with bond in the field.
Without the helpful lines to show you just how awful it is. Yeah, that really emphasizes what's going on there.
No, that really shows the importance of bonds between layers.
Oh, this is amazing.
I guess since we're talking about it, could you talk about the different tacking that is done, during different parts of the year?
Yeah, it's a different tacking. Tack is always, it's a very crucial part of the process, but tacks are made out of an emulsion, so you have to wait for the water to evaporate out of them for them to be cured and ready to pave on top of. And so obviously when you use a tack, it takes some time for the water to evaporate. In the summer it happens quicker, in the spring and fall it happens much slower. There's different types of tacks. There's a rapid setting tacks, there's quick setting, there's moderate setting tacks, there's different variances of tacks for different times of the year and different applications. But it's one thing at VDOT that we've come to find out and that we know is that tack is extremely important, especially on mixes that, especially with the way that we pave. Most of our paving occurs at night and in back-to-back or sequential nights. We have, we'll usually, if we're going down, say 3.5 inches, we'll place 2 inches on one night, come back the next night and do the next lift. If you fail to get that bond between lift 1 and lift 2 with the tack and get the right tack for the right time of year, then you see what can happen. You lose that bond and you've lost your asphalt. No matter how good your asphalt material is, the lack of bond causes each layer to act individually. With asphalt, we have the 3 basic mixes that we have. Is we have a base mix called a BM25 that we use. It's a larger aggregate asphalt mix. That's usually your first course. We have an intermediate mix, which has medium-sized aggregate, usually on the order of about 3/4 of an inch, 19 millimeters, and then we have surface mixes. And so there's different surface mixes we have. We have dense graded surface mixes that we use pretty much everywhere. So most places, most parking lots, Virginia Tech, anywhere else, you're going to have SM 9.5, which is a surface mix asphalt aggregate of about 3/8 of an inch. Out on the interstate, we use what we call a gap graded SMA mix, and the SMA stands for stone matrix asphalt, and it's basically this idea of taking out some of the fines and having more larger stone in it that can get stone on stone contact and make a stone skeleton, and you increase the liquid content, so it's more resistant to rutting, it's more durable. You use a polymer based asphalt liquid too, so it's expensive, but for interstate loading with truck traffic and all, it's very durable, and we've had very good success. But the success of a surface mix is only as good as what's beneath it, and that's true with all asphalt. Asphalt, you can have the best asphalt materials in the world, but if you have bad stone or bad subgrade, it's going to fail. One big thing with asphalt is keeping the mix, keeping your ingredients as dry as possible. It's all about keeping moisture out of the mix, and so some of the things they do is you'll see producers really pay attention to and work with their stockpiles, mixing their stockpiles, turning their stockpiles over, keeping them covered sometimes to keep them dry. With the wrap, that's one of our challenges, is the moisture that wrap likes to hold because of the asphalt component. It really holds on to moisture, and so that requires, to get that moisture out in the mixing process, means you have to crank the temperatures of your plant up. In fact, when they were trying to prepare for the 60% wrap earlier this week, they almost caught their plant on fire. They actually had a fire start in one of the drums. And,
oh my God.
But it was all contained, so they were able to put it out pretty quickly. But that was one of the dangers with the wrap, is that it can have a lot of moisture in it, so your operating temperatures have to get higher and higher and higher. And so keeping control of your materials that you're getting from your producers, that plays a big part. Just taking care of those, making sure that segregation's a big thing in materials too, because if you put down a stockpile of stone, the larger stone will tend to separate from the finer stone, and then you have to mix and rework that material in order to keep from having one spot of your stockpile that's all fines, one part that's all coarse aggregate, and then that can increase your variability in your mix too. So stockpile management is a huge part of asphalt production.
And what sort of testing do they do, like when they, or as they load?
Yeah, so what we're doing, we actually, right now, in this case, typically what we do is we do testing at the beginning of the season to get a good mix design ready, and we do spot check quality testing throughout the year. This, where it's all experimental, they're doing constant testing right now, so we're testing we're doing gyratory compaction in the lab, which is basically doing simulated roller compaction, and we're putting in a set amount of asphalt, compacting it, and checking the heights of that, checking the voids of that, and then that's one way that we can tell if something's off. If all of a sudden we're putting in the same amount of material, but our heights are different on our compaction samples, or our voids are different, then we know there's some clues there. And then there's gradation testing. We do a lot of gradation testing. The big thing with asphalt, the most expensive part of asphalt is the liquid asphalt, so we do burn ignition testing on a daily basis to check asphalt content, because asphalt content, 1/10 or 2% one way or the other, can change things very dramatically in liquid content, and as far as performance and resistance to long-term cracking, age degradation, stuff like that.
And earlier we were talking about some different materials or additives that you can add to increase the longevity and performance.
Rejuvenators, right. Yeah, so some of the research that we're doing right now is Virginia's looking into the use of rejuvenators. Rejuvenators are somewhat expensive, but with calculated usage, they can dramatically increase the performance of our pavement. What we're finding is that rejuvenators, as true to their name, they're almost like a fountain of youth for asphalt wrap, in that recycled asphalt's obviously old, deteriorated, oxidized asphalt, but rejuvenator can actually turn back the clock of time on the asphalt in wrap and help make it softer again. And so we're finding that by use of rejuvenators, we're getting a lot better compaction. And again, compaction and density on asphalt is longevity, because if a mix is not achieving good density, it's more open and more receptive to take in water, and water strips asphalt. Water makes asphalt ravel, creates potholes. But the tighter you get a mix, if you hit that asphalt content just right, you should repel water, and you should have a very long-lasting asphalt mixture. We were talking earlier, there's a very close working relationship between VDOT and the asphalt contractors. We have several associations, and I think Virginia really does a great job of getting conversation between the researchers, the contractors, and the DOTs, and we try to put together contracts and have open lines of communication where everybody knows what the expectations are, everybody knows what their issues are, and I think it helps us a lot to be at the forefront of the transportation industry in the United States. I think we have just as good of roads as anybody else in the country.
Yeah, I get the sense that's definitely the reputation.
Yeah, we definitely hold that proudly. So
I was telling him I've lived a lot of places in Virginia. It really does, by far.
Oh yeah.
Excellent roads.
Wow.
Yeah, we put a lot into communication with industry partners, especially in the asphalt industry. There's one group called the Virginia Asphalt Association, and they do a tremendous job of bringing industry and VDOT professionals together. They actually have been partnering with community colleges to make associates programs in asphalt production and placement and stuff, to give people an opportunity to gain the education to see what it takes to do asphalt, but also get some prerequisites down to where they could get their college experience started, and then if they wanted to, turn that into a higher degree. And so they put a lot of effort into that training process. I think it shows in the quality of work that we get.
Yeah. Wow. Well, this has been really informative, not just about the materials, but about the whole ecosystem. Of construction, the context in which this happened.
Yeah.
And then, so as somebody who surveyed pavement, I think PennDOT did a lot of their own maintenance.
Okay.
They're probably contracting more now, but what's how much does VDOT do? Does it contract most maintenance, or is that something done in-house?
So VDOT, we have crews that can do emergency maintenance, such as like pothole filling, or do small things at the drop of a hat. Now when it comes to patching or repaving long stretches of roadway, all that is contracted out. But we maintain basically a a skeleton force of sorts to handle immediate needs of a smaller nature, but anything of any size we contract out. We actually have very innovative contracting mechanisms in place, even some on-call patching contracts, to where same thing with guardrail replacement. We partner with contractors that can, we have hits contracts where a certain amount of guardrail gets hit, and then they identify that, and then the contractor will come out and replace that guardrail. And so, because that's the thing with the contractor, the costs are in mobilization and getting their equipment and their people in position to do something. And so we've partnered with them to say, well, if there was a critical guardrail hit, that one's got to be done immediately. But if there's ones that are deemed less critical, once those build up, then they can come through at one time and get a certain linear footage done at the same time. So that's why sometimes you see guardrail that might be dinged and it stays that way for a little bit. It's kind of I guess a compromise to contracting mechanisms to make it beneficial for them and us, as long as it's not compromising safety, because we always have that trump card with it.
Yeah, so Lanford Brothers is one of the big supporters of our program in civil.
Okay, yeah. No, we do.
engineering.
We work with them quite a bit.
I got to work with them on their headquarters building when it was being LEED certified.
Okay.
But some of the interesting things they talk about are, I think they were trying to pursue the roadkill maintenance contract.
Okay.
Somebody has to go and pick this up, and they were looking at equipment that they would have on site, so they bring trucks back with carcasses, and I mean, it was just somebody has to do it, but it's not something you think about.
Yeah, right. Yeah, absolutely.
And so all the stuff involved with highways, drainage, and
yeah, it's amazing. Leanne and I were talking earlier about, when I got started, I graduated Virginia Tech in 2004, and actually in structural civil engineering, and got started with an internship with materials at VDOT. And at the time, I thought, well, asphalt and stone, there's not really much to it, But then you get into it, and it's amazing how many applications and how much the DOT gets into. It's almost mind-numbing and blowing how much application there is. And Leanne and I were even talking about, we put such an emphasis on our materials that we use in all aspects of our operation, that we have a VDOT approved list of materials that we test, and we make sure that it meets our standards. And actually, we run into it all the time that other industries, even building industry, things far away from roadway, actually will specify needing materials in building construction that meet VDOT approved list number whatever. And it's because they recognize the scrutiny that we put our materials under, and that we put a lot of effort into the testing and acceptance of an approved list of materials. So I think that's a good badge of honor to have. Unfortunately, sometimes it's a little bit of a burden to test a material and say, well, I don't know that we're ever going to use this on a roadway. And somebody say, well, yeah, I'm doing this contract for a municipality for some buildings, and they specified that it has to be on VDOT's approved list. And we're like, well, that doesn't have anything to do with roadways. There's the asphalt.
So here we go.
Should be showtime.
Alrighty.
And then the rolling will go on for some time.
So is this an actual contract crew, or these aren't researchers?
No, this is the contract crew.
I was like, my God, they would never let somebody like me operate one of those.
Nor would I want to. I would do everything if I can't.
Wow, that's pretty cool, though.
No, there's Hobbs right there with BTTI.
Okay.
He works with Dr. Flint.
Oh, okay. Gerardo.
So he's checking the temperature of the loads and monitoring the compaction.
It looked like he was just shooting the surface temperature of the...
Yep. And so he's going to shoot the temperature right now when he comes out of the back of the truck.
Wow. I really had no idea. I guess I thought you could site adapt to conditions, but it sounds like you really can't do that.
Really. You kind of at the mercy of once it gets out on site, you either gotta put it down or wait.
Wow. What happens to the load if you don't use it?
They'll take it back and put it in the wrap pile at the plant. So yeah, they'll just take it and they'll dump it.
So it's not like concrete where you got to put a guy in the thing and have him chip it out.
No, it's not like that. So
Oh, thank God.
They'll just dump it into their wrap pile.
Still a waste though, I'm sure.
Yeah, I mean they'll get to use it at some point.
It's interesting to watch. This crew was just standing there and they came to life. I mean, how much of, I guess when you're paving, you pretty much have a continuous line of trucks waiting, right?
Yeah.
You're trying to.
Yeah, they got another truck. They've been shipping two, so it only takes 2 trucks to pave this 350 distance.
Better them than me. This looks like hard work,
Yeah.
for sure. So he's sampling there and is going to go.
Yeah, that must have been his pants.
And do you know what he does with those, or just?
I'm not real sure what he's doing with his. I know in the mix we did yesterday, North Carolina DOT was interested in it, so we had to sample some and send them to North Carolina yesterday. So I'm not sure what they wanted to do. I know there's a lot of people doing a lot of sampling for those.
Yeah.
At the plant, they had about 60 boxes or so that they were sampling full of this. So I think some of it will be tested on. They can reheat, and they'll do some reheating testing too. But that's one of the things too is finding testing that replicates what's done in the VDOT. And so one of the things is we've been putting a big effort in getting the mix while it's hot and preparing test specimens while it's hot. But most of the times, because the asphalt production happens at night and we're doing quality assurance testing, we have to take the mix, it cools, and you have to reheat it. So one of the things being looked at too is what does that reheating process do to the mix? Does that compromise your mix to where your test results aren't representative of what the mix is when it's initially produced? Or is there still some correlation that you maybe increase values by a percentage because it was reheated versus compacted while it was sprayed hot? There's a lot of people looking at a lot of different things with this mix.
So I see they're filling in where must be the saw cuts where samples were taken out, or what are they? I don't know. Wait, no, they didn't do that in that lane.
I think they're spreading. They got a pretty good buildup in front of that paper, so they're trying to spread it out.
Okay.
A little bit, so because that'll be a big bump. But that's one reason why the first test section is some distance in front, because when you're starting out, there's some variability that can occur.
So I wonder what he's adjusting with that crank. The guy in the corner, there's a crank there. And he just tweaked it a little bit. Wonder if that's a depth adjustment or something? You see what I mean? That magic red lever there.